Hello. Today we are going to discuss about Chapter 7, Project Management. Project Management is an important operations management tool that the firms such as Microsoft use to organize many activities in the project. Project management can be a tool that can be used to organize small projects or large projects. And within the project management, projects are an interrelated set of activities which are definite starting point and ending point, resulting in a unique outcome of a specific allocations of resources. Projects can be common in everyday life, such as organizing a carpool, organizing a birthday party, organizing a wedding, or can be a big task, such as building the university, building a big building. There are three main goals to complete the project. First goal is to complete it on time. Second goal, to not exceed budget. And the third and important goal is to satisfy customer. Project management is a tool which is a systematic phase approach that we can use to define, organize, plan, monitor, and control projects. Projects often require resources from many different parts of organization. Even though sometimes projects like building houses look almost the same, but every project is unique. Every house is different, and mostly projects are temporary. People get together doing something. Once the project completion is completed, then people are moving on to the next project. When you have many projects that going on at the same time, sometimes we call it a program. There are three different activities in project management. First activity is defining and organizing project. Second, planning project. Third, monitoring and controlling project. The first activity, defining organizing projects. We use to define the scope, how large the project will be, time frames, when the project will start and when it will be done, and the resources that need to be allocated to. And this project, in this stage, we also select the project manager, which is the project leader, and also the project team member. Mostly project manager will be a good facilitator, good communicator, and a good decision maker. Team members sometimes have technical competency, sensitivity, and dedication toward his or her own task. The second activity, planning project. In this stage, the project will be laid out in different small tasks. We can use different tools to organize these tasks into a systematic group. So these two may include work breakdown structure, network diagram, critical path, cost-time trade-off, and assessing risk. Work breakdown structure, or WBS, is the tool that can be used to state the main goal of the project. Work breakdown structure is a statement of all tasks that must be completed as part of the project. In the work breakdown structure, we will put an activity, which is the smallest unit of the work, into an organized manner. Take a look at this figure 1. The project is to relocate the St. John Hospital. The project has two main projects. The first project will be organizing and site preparation, and the second project will be infrastructure. And for each project, the work will be broken down into small little tasks or activity. For each task or activity will have their own its owner. Once the work breakdown structure is done, then the project can be organized into a systematic manner using a network diagram. The network diagram we are going to use, we call precedent relationship diagram. We are going to use the circle or node to represent an activity. We are going to use an arc or an arrow to represent the relationship. We call this approach activity on node approach. Node represent activities, arc represent relationship. So for activity on node approach, there are many outcomes that might happen. Normally, project activity, we will use a letter character to represent the activity inside the node. For example, the first picture represents activity S precedes activity T. Activity T precedes activity U. You can see that the arrow represents the relationship between S and T and between T and U. Sometimes there are more than one activity that lead into one activity. Such example will be the second picture. Both activity S and T must be completed before activity U. So there are many possibilities to use activity on nodes. Okay, once you finish activity on node approach, we are going to draw the network activity out. This picture represents an example of St. John Hospital project. The first column represents activities. You can see that an activity will start with a letter A, B, C based on alphabetical order. Okay. Normally we don't put activity description inside the note. We only put the character, but we must have second column, which is the activity detail. For example, activity A, select administrative staff, and the third column represents immediate predecessor, which means before this task is started, what kind of task that precedes this task. You can see that task A and B has no immediate predecessor, therefore A and B is the starting point of the project. And fourth column represents activity time, which is time in weeks in this particular example to complete the project. And last column represents the responsibility or the owner of the project. Okay. And you can see that sometimes in many occasions one person can be responsible for more than one activity, and some activity can also be started at the same time. Once you have all these activities planned out, you can start using the activity non-node approach to draw the network. You can see that according to the relationship, activity A and B starting the project. So we put the starting point in the box. Sometimes the box like this, we use the term milestone. We put activity time inside the circle underneath the letter character to represent activity time. Okay, and after activity A is done, activity A is an immediate predecessor for D, F, and I. So therefore, A will lead to I, F, and C. Okay, and you might have a question: why didn't they order put C over here and F and I according to the alphabetical order? There's nothing wrong with it. You can use different kind of method. I think the book trying to do it to make it clean, so for the students, so you guys are not confused. But when you draw the network diagram yourself, the line can be crisscross. As long as you understand it, that's fine. Okay, and then you just keep going until you reach activity K. You can see that activity K is the last activity. Once you reach the last activity, then activity K will lead to finish another milestone. Okay, once we finish the activity network diagram, we are going to accessing the path. Now, path is a network of activity from start to finish. For example, in this particular example, we have AIK one path, AFK another path, ACGJK another path, and once you identify all paths, Then you add the completion time of all paths of all activity in the path together. You will see that activity A IK 12 plus 15 plus 6 is 33. Okay, of all paths, you will recognize that at least one path will have the highest estimated completion time. And we call that path the path with the highest completion time a critical path. As you can see in this picture, most of the time project the critical path will be highlighted with different color. In this particular example, we use red to represent a critical path. BDHJK is a critical path. Okay, now for another example, you can try on your own, or you can watch another video explaining how to draw a critical path. Okay, once the network diagram is identified or is drawn, next step is to identify the schedule. The schedule is the process to identify the starting time of each activity and the finish time of each activity. Okay. For example, in order to identify the starting time, we need the earliest start time or ES, and we need earliest finish time EF. We need latest finish time LF and latest start time LS. So the notation can be used. Okay. On this picture, you can see that for a single activity, you must have ES and EF on the top part of the activity, LS and LF at the bottom part of activity. ES is located on top left, EF is on the top right, LS bottom left, LF bottom right. Okay, so we call this process scheduling. And once we finish scheduling, we can also identify slack. Slack time is identified as the difference between the front pair, or the difference between LS and LF and ES, or the difference between LF and EF. So particular example, the number should come out the same. 48 minus 12 is 36, or 63 minus 28 is 36. Okay, and in order to do that, we are going to go to the next slide. When we identify the schedule, first we perform the front part or the forward part to identify ES and EF. The ES is called earliest start time. It is the earliest time to start of the project. For example, activity A and B has no immediacy predecessor, so ES will be 0. EF will be the ES plus activity time of that project. For example, activity A, EF will be 12. Activity B, EF will be 9. Okay, and for activity that comes after activity A should be started when activity A is finished. In this particular example, activity I, F, and C are done are started once A is done at 12. So I, F, C are started at 12 same time. Okay, and there will be some occasion that there are two activity, like in this particular example, there are at least 3 activity that lead into one activity. Activity G, H, and E all are completed before J can be started. In this particular example, we will use the largest value of the EF of the previous activity. So in this picture, the largest value of EF for the previous activities is 59. So therefore 59 is used for the EF of activity J. For the bottom part, you must start it backward from the finish line. So at the finish line, activity K is the last activity. Activity K has EF of 69. Therefore, 69 is the completion time, or the largest value of number you get from the forward process. When you start the backward process, you start with 69 at bottom right as an LF, then start subtracting number of activity time of activity out. For example, activity K, you subtract 6 out of 69, get 63. Then 63 becomes LF of J. Then start subtracting 4 out of 63, you get 59. Okay, so you can see when they are going backward, you may have one activity that branch out into more than one activity. For particular example, activity A branches into I, F, and C, and each has different LS. When you go backward, you use the smallest LS to become an LF of previous activity. For example, activity A, you compare between 48, among 48, 53, and 14. Then you select 14 as the smallest of the group to become an LF of activity A. Then you subtract 2, you get, okay. So for this particular example, you can see that activities may have different slack value. The slack value is the number, the difference between the front part the front pair or the back pair. Each different activity may have different slack time. As you may recognize, on the critical part, all activity slack must be zero. And let me emphasize that when you do the process right, you should get at least one activity that have zero LS, at least one activity that have zero LS. If you do not do it right, you end up have none activity that have zero LS. Then you have to go back and try to figure which part you do wrong. Okay. Now let me review the concept again. Activity slack is the maximum length of time an activity can be delayed without delaying entire project. Of course, on the critical path had no activity slack, and therefore if you delay any activity on critical path, you will delay the completion of the project. Okay, and I hope that you use the exercise I give it to you and try to complete the example along with me with the video I provided. Now, next concept is about risk. Risk is a measure of probability and consequence of not reaching a definite goal. Mostly the definite goal can be resources constraint. Risk may come from many parts of the project. Risk may come from the strategic part, or come from the attribute part, or sometimes come from the team capability and or the operation of the project. When you assess risk, sometimes to protect project managers, protect themselves against the risk that may happen, we can come up with 3 different sets of completion time. The first one, when you feel optimistic, or A. The optimistic time will be the shortest time that each activity can be completed. So when there's nothing goes wrong with the project can run smoothly and take the shortest time. And second option will be most likely time, or M. And third, when you feel pessimistic about the project, B, or pessimistic time will take a longer time. So when managers feel there's something wrong with the project and the project will last longer than the last 2 times. Okay, and according to statistic analysis, the three types of three sets the 3 types of time we use to complete a project will follow beta distribution. which is somehow look like a chi-square curve leaning toward the lower value instead of a normal distribution curve. The risk-related term will follow beta distribution curve. As you can see from the picture, the top picture, A optimistic term is the lowest term. M most likely term will be in the center, skewed toward the left, and the pessimistic term B will be the largest term. Okay, based on beta distribution, the estimated term we use TE equal A plus 4M plus B divided by 6, and the risk of not completing activity on time is going to follow beta distribution as well. We call variance. Variance represent the risk associated with not completing the activity on time equal, in parentheses, B minus A divided by 6 squared. So according to this activity example, for this example, we can estimate for each activity the expected time come from the optimistic term plus 4 times most likely term plus B pessimistic term divided by 6. And the variance comes from B minus A divided by 6 and square. You can see from this picture that the last column, variance, will tell what type of activity are not likely to finish on time. For example, activity I have the higher risk to not be completed on time. Yeah. Activity A, on the other hand, the variance is very small, meaning that activity A is likely to be completed on time. Okay, once you assess the expected time and variance, you can use that to identify the probability of the project to be completed on time. If you use the term of probability, means percent that project will be completed on time. And we use the Z transformation to figure out the percent probability of the project to be completed on time. T represent the project due date. TE represent the expected time from the calculation. The bottom part is square root sigma square is the summation of variance on the path that we are interested, can be critical path. Let's look at example 7.5. Example 7.5, St. John Hospital. The St. John Hospital has a critical path is BDHJK. The completion time is 69. We would like to know what percent probability that project will be completed in 72 weeks as opposed to 69 weeks. Okay, and just so you know, if you are talking about normal distribution curve, the project will be completed in 69 weeks for about 50% or half of the curve. To complete it more than 69 weeks, that tells a little bit that project will be completed beyond 50%. So we use C transformation. We use 72 weeks to start with. Subtract critical path 69 weeks divided by square root of the sum of the variance or the critical path 11.89, and we come up with the z value of 0.87. Okay, with the z transformation or normal distribution curve, appendix 1 in the back of your book, you can convert the z value 0.87 into about 80.78%. Okay, based on this picture, you can see that using a normal distribution curve, the project will be likely to complete in 69 weeks in 50%. To complete more than 69 weeks, the percent will be beyond 50%, meaning that you have more chance to complete it. So in this particular example, the area under curve from 0 to 72 weeks represent the percent the project will be completed within 72 weeks. Okay. Or sometimes we can also estimate the project on any particular path, how much percent it will be completed. For example, if we are not interested in the critical part, we are interested in a certain part, assuming ACGJK. We can also use ACGJK 67 to compare with 72 on the top, and the bottom part we use the summation of variance or on ACGJK. And you can see, based on the C transformation, the project for this particular will be about 90%. Okay, I think we will use many examples on the exercise. And the last stage of the project is to monitor and control the project. Once the project is launched and ongoing, project manager must use some type of tool to track the progress of the project. And this task should be done as an ongoing basis. Why we have to do that? To monitor and control the project, just to make sure that everything runs smooth, or if there is any problem. Sometimes the problems can be detected earlier and dealt with quickly. Okay, and the problem that may arise from the project may be from resource problem, allocation problem, or acquisition problem. And the last activity for the project is called project closeout, which is the write-up of the final report. And normally in the final report, the project manager will compile all recommendations of the team member, just in case the project has to be done again. Then the feedback can be used looking for the next project. Okay, I think that is it for the concept part. I'm looking forward to see you on the exercise video. Thank you so much.